Download this code from codegive.com, link in the description below. OK, let's dive deep into React Native's inner workings, exploring how it bridges the gap between JavaScript code and native platform functionality. I'll incorporate Rotem Mizrachi meidan's insights and address common areas of confusion. Tutorial: React Native under the hood. Introduction: the React Native magic. React Native allows you to build native mobile applications using JavaScript and React. Unlike hybrid approaches, like Cordova, React Native doesn't render within a web view. Instead, it uses JavaScript to manipulate native UI components. This results in apps that feel more performant and look more native. The core principle is to write once, run everywhere, within reasonable limits, of course. Core components and key players. To understand React Native's mechanics, we need to dissect its main parts. 1. JavaScript code, your React components. This is the JavaScript code you write, using React components, functional or class-based, and JSX syntax to describe the UI. 2. The JavaScript virtual machine, JavaScript core/Hermes. React Native uses a JavaScript virtual machine, VM, to execute your JavaScript code. Traditionally, it uses JavaScript core, provided by the host platform, such as Safari on iOS or the system's JavaScript core on Android. React Native also supports Hermes, a JavaScript engine optimized for mobile, which is generally preferred for performance reasons. JavaScript core, JSC comes built in with iOS and Android. It's the default but not necessarily the most optimized. Hermes created by Facebook specifically for React Native. It optimizes performance by performing ahead of time, AOD, bytecode compilation, reducing startup time and improving performance especially on lower-end devices. Hermes is now the recommended JavaScript engine. 3. The bridge, asynchronous communication. This is a crucial component. It's the asynchronous communication layer that facilitates data exchange between the JavaScript VM and the native platform code, Objective-C/Swift on iOS and Java/Kotlin on Android. The bridge is based on a serialized message passing system. It handles converting data structures, JSON, between JavaScript and native formats. 4. Native modules. These are platform-specific modules written in native code, Objective-C/Swift on iOS and Java/Kotlin on Android. They expose native functionality, example camera access, geolocation, push notifications, accessing hardware sensors, to JavaScript. 5. Native UI components. These are the actual native UI elements, example UI view on iOS, Android.view on Android, that are rendered on the screen. React Native provides a set of built-in components, view, text, image, scroll view, etc., that map to corresponding native components. You can also create custom native components when needed. The data flow, a step-by-step journey. Let's trace the path of data and events within a React Native application. 1. Component update, JavaScript. When your React component's state or props change, React's reconciliation algorithm determines the necessary UI updates. 2. Serialization, JavaScript. The UI updates, described in terms of React Native's abstract UI component representation, are serialized into JSON messages. 3. The bridge, asynchronous transfer. These JSON messages are passed asynchronously over the bridge to the native side. This communication is not synchronous to avoid blocking the UI thread. 4. Deserialization, native side. The native side receives the JSON messages and deserializes them. 5. Native component creation/update, native side. Based on the deserialized data, the native modules create or update the corresponding native UI components. For example, A text component might be translated into a UI label on iOS or a text view on Android. 6. Rendering, native side. The native components are rendered by the operating system, resulting in the UI displayed on the screen. 7. Event handling, native side. When a user interacts with the UI, example taps a button, the native UI components generate native events. 8. Event serialization, native side. These native events are serialized into JSON messages. 9. The bridge, asynchronous transfer. The JSON messages containing event data are sent over the bridge to the JavaScript side. 10. Event handling, JavaScript. The JavaScript code receives the event data and executes the appropriate event handler, example a function associated with the buttons on press prop. 11. Component update, JavaScript, cycle repeats. The event handler might update the component's state, which triggers a new reconciliation cycle and the whole process repeats. Code example, a simple button. Let's illustrate with a simple button example. Explanation of the code and under the hood process asterisk. 1. JavaScript component, meidan example. We define a React component with a touchable opacity, which maps to a native button equivalent. 2. Initial render asterisk. Asterisk. When the component mounts, React generates virtual DOM nodes for the view, text, and touchable opacity elements. Asterisk. React Native translates these virtual DOM nodes into instructions for the native side. Asterisk. The instructions are serialized into JSON and sent over the bridge. Asterisk. On the native side, iOS or Android, the corresponding native UI components are created, UI view, UI label, and a native button, like UI button on iOS or Android. Widget. Button on Android. The styles are applied to the native components. 3. Button press asterisk. Asterisk. When the user taps the button. Asterisk. The native button component triggers a native event. Asterisk. The event is serialized into JSON and sent over the bridge. Asterisk. The JavaScript side receives the event and executes the handle press function. Asterisk. Handle press calls set click count, updating the component's state. Asterisk. This state update triggers a re-render. The process from step 2 repeats, but only the text component showing the click count is updated because React's reconciliation determines that's the only part that needs changing. Asterisk. The alert.alert function uses a native module, specifically the alert module, to display a native alert dialog. This involves another communication across the bridge to trigger the native alert implementation. Native modules, bridging the gap. Native modules are crucial for accessing platform-specific functionality that isn't directly available in JavaScript. Let's outline how to create and use a native module. Example, a simple Android native module to get device ID. 1. Android, Java/Kotlin. Asterisk. Create a new class that extends React context-based Java module. Asterisk. Create a class that extends React package to register the module. Asterisk. Register the React package in your main application.java. 2. JavaScript asterisk asterisk. Asterisk. Access the module using native modules. Explanation asterisk. Asterisk. Example device ID module.java asterisk. Asterisk. Extends React context-based Java module, providing access to the React native context. Asterisk. Get name, returns the name the module will be known by in JavaScript, example device ID module. Asterisk. At React method, marks a method as available to be called from JavaScript. The getDeviceID method fetches the Android device ID. Asterisk. Promise, this is a special React native type that allows the native module to return a result asynchronously to JavaScript. Promise.resolve, sends a successful result, and promise.reject, sends an error. Asterisk example device ID package.java asterisk. Asterisk implements React package to register the module with React Native. Asterisk create native modules, creates an instance of your native module and adds it to the list of modules that React Native will make available. Asterisk main application.java asterisk. This is where you register the example device ID package so that React Native knows about your custom module. Asterisk device ID component.js asterisk. Asterisk imports native modules from React Native. Asterisk accesses the module using native modules.example device ID module. Asterisk calls the getDeviceID method. Key considerations for native modules asterisk. Asterisk thread safety asterisk. Be very careful about thread safety in your native modules, especially when interacting with the UI or other sensitive resources. Use appropriate synchronization mechanisms, example locks, if necessary. Asterisk error handling asterisk. Implement robust error handling in your native modules. Return meaningful error messages to JavaScript so that the app can gracefully handle errors. Asterisk data conversion asterisk. Pay attention to data type conversions between JavaScript and native code. React Native provides utilities for converting common data types. Asterisk memory management asterisk. Be mindful of memory management in your native modules, especially when dealing with large data structures or long-running operations. Use appropriate memory management techniques, example Arc on iOS, to prevent memory leaks. Asterisk permissions asterisk. If your native module requires access to sensitive user data, location, camera, etc., you'll need to request the necessary permissions from the user using the platform's permission APIs. Asterisk asynchronous operations asterisk. Native modules operations are generally asynchronous. Make sure your native module is designed to handle operations that take a longer time to execute so as not to block the app. Performance optimization tips asterisk. Asterisk use Hermes asterisk. Hermes provides significant performance improvements, especially on Android. Asterisk minimize bridge crossings asterisk. The bridge is a bottleneck. Try to minimize the number of messages sent across the bridge. Batch updates when possible. Asterisk optimize image loading asterisk. Use optimized image formats, example WebP, and consider using a library like React Native Fast Image for efficient image caching and loading. Asterisk use should component update or react.memo asterisk. Implement should component update for class components or react.memo for functional components to prevent unnecessary re-renders. Asterisk virtualized lists asterisk. Use flat list or section list for rendering large lists of data. These components virtualize the list, rendering only the items that are currently visible on the screen. Asterisk code push asterisk. Utilize code push, or similar tools, to deploy JavaScript updates to your app without requiring users to download a new version from the App Store. Asterisk profiling asterisk. Use React Native's profiling tools, built-in or third-party, to identify performance bottlenecks in your code. Rotem Mizrachi meidan's perspective. Rotem Mizrachi meidan, a prominent figure in the React Native community, has emphasized the importance of understanding the bridge and native modules for building performant and reliable React Native applications. He has also highlighted the significance of using tools like Hermes to optimize JavaScript execution. He's advocated for a deep understanding of the native side to be able to debug and solve complex issues that arise when integrating with native APIs. Common challenges and debugging. Asterisk bridge bottleneck asterisk. The asynchronous nature of the bridge can be tricky. Pay close attention to the volume of data transferred across it. Asterisk native module issues asterisk. Debugging native modules requires platform-specific knowledge and tools. You'll need to use Xcode, iOS, or Android Studio, Android, to debug native code. Version mismatches ensure that your React Native version, native dependencies, and tooling versions are compatible. Incompatible versions can lead to unexpected errors. Conclusion: React Native provides a powerful way to build native mobile applications using JavaScript and React. Understanding its architecture, including the JavaScript VM, the bridge, and native modules, is essential for building performant, reliable, and maintainable apps. By embracing tools like Hermes, optimizing bridge communication, and mastering native modules, you can unlock the full potential of React Native and deliver exceptional user experiences.